Okay, here's the second video for 10.3. We're going to sketch the curve r is equal to the sine of 2 theta. We can do the same thing we did before where we put in different values of theta and see what the r value is and plot those. But here's kind of a way to fast sketch these. You could just consider the Cartesian equation y is equal to the sine of 2x and plot this to help you figure out what's going on with the polar coordinates. So if we were to sketch y is equal to the sine of 2x, the b value is 2, so the period is 2 pi divided by 2, which is pi. We take pi and divide it by 4, that's going to give us our spacing for our sine graph. So this would be pi over 4, this would be pi over 2, 3 pi over 4, and pi. It's going to finish the cycle in just pi units, okay? Since it's a sine wave, it starts in the middle, and then it goes up to 1, middle, then down to -1, and then middle. So this is what our sine wave looks like. It's our sketch, okay? So with that in mind, we can figure out the polar sketch of this by just kind of watching what's happening. This is our pole, and this is the angle 0 right here. So at 0, it's at 0. That's the first point. Okay. Then at pi over 4, which is this angle right here, right? What's happening? It's 1 unit out. So let's call this 1 unit out. It's here. And then at pi over 2, it's back at 0. So once we get here, it's back at 0. So our curve is doing something like this, and then it's coming back to 0. And then if we continue, what's going to happen when we get to 3 pi over 4? Well, when I get to 3 pi over 4, which is here, it's at -1, which means I'm all the way out here at -1. So it's going to do this next, and then it's going to come back in. So what's happening is it's making these loops. This is one cycle, but if I went on and continued through 2 pi, I could follow the points, and what it's going to do is it comes in here, and it's going to go up and down and down and down like that. So I'm not sure if I did that. Let me see if I did that in the right order. When I come to, what is this? 5 pi over 4, I'm up at 1. So I'm at 5 pi, yeah, up at 1. Yeah, so that's what it does. It's going to go here, here. Now, even though my little loops look different sizes, that's just because I'm sketching and didn't do a good job. These are symmetrical if you were to graph it accurately. Okay, so that's an example of how you can fast sketch a curve. Example 7, they just give us a graph and say, okay, sketch this guy. So let's see, what could we make the polar sketch of this guy? So let me label my axis. This will be, this is the polar coordinate. Polar graph of that. Okay. Let's see here. So, and what I don't have here is the little grid marks, okay? That's what, this is the same graph as the one that has all the circles drawn on it, even though I didn't have that little template for us to use there. Okay, example 7, use the given figure. The given figure shows r as a function of theta. Use its sketch to sketch the corresponding polar curve. Okay, so this is basically like what I did here, okay? And so we could sketch, if we're given this and we need to plot our polar coordinates, we could say, well, what's happening when theta 0, r is 0.5. So if this is 0, let me guess, so let's say this is 1 and this is 0.5 and this is 1.5 and this is 2. Maybe I'll make it right there. Okay, so let's see what's happening here. Let me go up. This is where 2 would be here. This is where 1 would be. This is where 2 would be. This is where 1 would be. This is where 2 would be. This is where 1 would be. Okay. So it says when theta is 0, r is 0.5. So we're right here. Then when theta is pi over 2, up here, r is all the way up at 2. We're all the way up here at 2. Okay. And then when theta is pi, so when we're over here, r is 0.5. So we're back here at 0.5 when we're at pi. And then at 3 pi over 2, we're back up at 2. So we're at 3 pi over 2, we're going to go 2. Because remember, this is 0, this is pi, this is pi over 2, this is 3 pi over 2. And then when we get to 2 pi, we're back at 0.5. So what we've got here is something that kind of goes like this, and then this, and then this, and then this. Maybe I'm making it I'm not making it curvy enough. But this is the basic shape of what we'll get for this guy. All right, let's look at example 8, which says, now we get to find derivative. So to find the derivative of a polar graph, we're looking for dy dx. Dy is just the derivative of y with respect to theta. Dx is derivative of x with respect to theta. So this is the formula. How do we come up with this? Well, we recall that y is equal to r times the sine of theta, right? And x is equal to r times the cosine of theta. Well, how do we get this? We use product rule. Remember that r is a function of theta. So chain rule is going to be involved right here. This is a function of theta times a function of theta. So if we take the derivative of y with respect to theta, it's going to be first r times the derivative of the second, cosine of theta. So this is y prime. Plus second, the sine of theta times the derivative of the first, dr d theta. All right. And so what they have here, y prime is dy d theta. That is this numerator, but they have it written in different order. They've commuted the addition and they've commuted the dr d theta in the sine. So this is what we get for y prime. X prime, product rule, gives us, I do first times the derivative of the second, negative sine theta, plus second, cosine of theta times the derivative of the first, dr d theta. So we can come up with the denominator here with some rearranging of terms, commuting dr d theta, cosine, they switch those, and then minus r sine theta. So this is the generally held formula for dy dx for polar coordinates, the tangent. So in example 8, it says find the slope of the tangent line to r is 2 plus sine of 3 theta, where theta is pi over 4. All right, to find the slope of the tangent line, we find the derivative, and we evaluate it at theta is pi over 4. So dy dx, first let's find dy d theta is going to be over dx d theta, over dx d theta is equal to, by formula, dr d theta. Okay, here's r. What is dr d theta? Dr d theta is going to equal to the derivative of 2, which is 0. Derivative of sine is cosine. So this is going to be the cosine of 3 theta times the derivative of the angle 3 theta, 3. That's chain rule. So this is what dr d theta is. So dy d theta is equal to dr d theta, which is this right here, 3 cosine of 3 theta times the sine of theta plus r, which is this right here, 2 plus the sine of 3 theta times the cosine of theta, all over dr d theta, the same thing, 3 cosine of 3 theta cosine of theta minus r 2 plus the sine of 3 theta times sine of theta. Okay, now they want this evaluated where theta is pi over 4. So let's do that. This is going to be 3 times the cosine of 3 pi over 4 times the sine of pi over 4 plus 2 plus the sine of 3 pi over 4 times the cosine of pi over 4 all over 3 cosine 3 pi over 4 cosine pi over 4 minus 2 plus the sine of 3 pi over 4 times the sine of pi over 4. All right, pi over 4 is right there. 1 over square root of 2, 1 over square root of 2. 3 pi over 4 is right there. Negative 1 over the square root of 2, 1 over the square root of 2. So this becomes 3 times negative 1 over the square root of 2 times the sine of pi over 4, 1 over the square root of 2, plus 2 plus 1 over the square root of 2, negative 1 over the square root of 2, all over 3, negative 1 over the square root of 2, 1 over the square root of 2, minus 2 plus 1 over the square root of 2, 1 over the square root of 2. All right, here we go. Square root of 2 times the square root of 2 is 2. And we have 3 times all of that. So this is going to be negative 3 over 2 is what we get right here. Plus, this term will distribute. Plus 2, or it's going to be minus 2 over the square root of 2. Minus 2 over the square root of 2. And then 1 times 1 is 1. Square root of 2 times square root of 2 is 2, but it's going to be a negative 1/2. That's what we get in the numerator. Denominator, we have 3 times a negative, which is negative 3. Square root of 2 over square root of 2 is 2. Again, this will distribute, so it's going to be minus 2 over the square root of 2 minus 1 over 2 is what we get there. All right. What do we get here? It looks like we're getting the same thing over the same thing, which makes me wonder if that's right. Let me check my signs real quick. I'm going to pause just a second.